I will come back with a new physics lesson for grade 10. This lesson will speak about sound wave. Sound wave is longitudinal wave or compression waves. Answer task. This question we will answer about it at the end of this chapter or at the end of this lesson. In your notes, answer the following questions. Do sound waves travel faster in solid, liquid, or gas, and why? How are musical notes made with a wind instrument like clarinet? How does one string on guitar make different musical notes? Using wave theory, explain how making sound with a wind instrument is essentially the same as making the sound with a string instrument. Of this question, we will ask about it at the end of this lesson. Sound wave. Characteristics of sound wave. Sound waves are caused by vibrations. Any material or any object can vibrate, make sound, and carry energy through medium. We know that before. Waves just carry energy, didn't move the matter, but carry energy through the medium. Medium, it means solid, liquid, gas, any matter. The speed of sound, a particular medium, depends on how well the particles can transmit the compressions and rarefactions of sound waves. What does it mean, compressions and rarefaction? If we see this line, this is closed line called compressions. This is spread line called rarefaction. Compressions, it means high pressure. Rarefactions means low pressure. The distance between the center of compressions and the next compressions, we call it wavelength. Also is the distance between the center of rarefaction and the next center of another rarefaction. Like this. This is wavelength, this is compressions, and this is rarefaction, and this amplitude is line density. Properties of sound wave. Loudness is determined by intensity. Loudness, high or low, is determined by intensity. Intensity depends on the amplitude of the sound wave as well as your distance from the source of the waves. The greater the intensity of the sound, the louder the sound will seem. It means if the intensity of the sound is greater, the sound will be louder. But intensity, what's the meaning of intensity? Intensity depends on the amplitude. What's the amplitude? Yes, is the highest or lowest point can the wave reach at, or the thickness of compression and thickness of rarefaction of the sound wave, as well as your distance from the source of the wave. When you was near or close the sources of the sound will be louder or intensity of the sound will be greater. But when you move away from the source of the sound will be quietly. Sound intensity and decibel. What's the meaning of decibel? Decibel is the unit for measuring sound. This is pictures give a measurement of the sound intensity by decibel and different sound like plane, like saw, like cat whisper, different thing. And we must see the change in the wave of the sound, amplitude also, and frequency or wavelength. Properties of sound. Low frequency sound waves, high frequency sound wave. It means how many complete waves in this distance. I will see the distance between two crust or two trough. It will be the wavelength. So how many crust or trough here? How many complete wave here? 1, 2, 3, 3.5, 3.5 waves, complete waves. But in this, about 1, 2, 3, 4 and half, 4.5 in the same distance, so I have more complete wave in the same distance. So this is high frequency sound wave and this is a low frequency sound wave. The first is pitch. The first properties, we have three properties. The first property is pitch. Pitch is determined by frequency. It means the pitch is measured of how high or low sound. High or low sound. Pitch, yes, measure how high or low sound is perceived to be depending on the frequency of the sound wave. So, high frequency, high pitch. Low frequency, low pitch. High frequency, it means sound is high. Low frequency, it means sound is low. High pitched sound corresponds to high frequency and low pitched sound corresponds to low frequency. Doppler effect. Frequency changes when the sources of waves is moving. It means not all sound sources is fixed. Some sources is moving, like plane, like truck, like car. Many things, many objects can move and make sound. So the Doppler effect is an observed change in the frequency of the wave when the sources or observed is moving. Doppler. We will see animation speak about Doppler effect. This is V over V sound. This is the speed of the object and this is the speed of the sound, and this is the object which represent the sources of sound. Now the relation between the speed of the object and the speed of the sound is zero. It means the object is fixed. So if we see, we can see that the distance between the front of waves between the two lines is equal to behind the object is equal to the distance between front wave in front of the object. Okay, I will start move this object front by about half of the sound of half speed of the sound wave, like this. What happened? We can see that the distance here will be more or larger than the distance between the two lines or between the front wave at front of the object. It means when the object starts moving, we will have a change in frequency behind the object and the front of the object. This is called Doppler effect. But if the object move with a ratio greater than 1, it means the speed of the object will be greater than the speed of the sound. What will happen? Now this object will moving faster or moving with speed more than the speed of the sound, so I can't hear this object. If I stand here or the observation stand here, he can't hear the sound of this object until he pass him by a great distance. Properties of a sound. We continue with the properties of sound. Humans hear sound waves in limited frequency range. Any sound with frequency below the range of human hearing is known as an infrasound. We take another word in light. When we study light, it's called infrared. Infrared, ultra and ultraviolet. Infrared, it means the waves or electromagnetic wave that is behind or before the red light we call infrared, and we can't see it. So also sound before the range we start to hear, it's called infrasound. And infrasound is slow vibrations of frequencies lower than 20 hertz. Hertz, it means one wave in 1 second. Any sound with frequency above human hearing range is known as the ultrasound. An ultrasound is any sound wave with frequencies higher than 20,000 hertz. Now we will see different applications about sound, ultrasound and sonar. Ultrasound imaging is used in medicine. We all see this device to see inside our body without opening our body. We use ultrasound. The echoes of very high frequency ultrasound costs between 1 million and 15 million hertz are used to produce computerized images called sonograms. Sonograms is a picture constructed or produced by computerized program due to using echoes with very high frequencies, ultrasounds between 1 and 15 million hertz. Some ultrasound waves are reflected at boundaries. Some sound waves are reflected when they pass from one type of materials to another, and how much sound is reflected depends on the density of the materials at each boundary. It means the sound penetrates, ultrasound penetrates some materials, but this penetration depends on the intensity of the material or density of the material. It means if we have high reflected ultrasound, it means the materials is high density. But if we have low in reflected ultrasound, it means the materials is low density. So I can predict the material density inside the body with using ultrasound and sonograms. Sonar, a sound navigations and ranging in a system that uses acoustic signal and echo returns to determine the locations of objects or to communicate. We use this when we're sailing in the ship because it gives me information about the bottom of the sea or ocean. Sonar is used for underwater location. Sonar system determines distance by measuring the limit it takes for sound waves to be reflected back from the surface. We know that when we know the speed of the sound and the time taken to travel and back, it means I can determine the distance. From this equation, d equal v t. D is the distance between the source of sound and the object which is reflected from it. V, average speed of the sound wave in water. T is time. Thank you and goodbye with you.